Geotechnical Engineering Part A, Soil Mechanics Session 4, Weight-Volume Relationship. In this example, we have a saturated clay soil with a wet mass of 318 kg and a dry mass of 204 kilograms. The total volume provided of sample is 0.193 cube meters. We want to know what the specific gravity of the sample is, so we want to calculate GS for the sample. So data provided are again wet mass, dry mass, and total volume of the sample. Let's solve the problem. For calculation of a specific gravity, we need two components. First is E. In this equation, we do need to have E and water content. We already know SR because the sample is fully saturated, so SR is already 1 for a 100 saturated or fully saturated soil. So we already know what SR is. We do need to calculate it to two component of void ratio and water content. Then we can easily calculate GS. So first attempt the calculation of void ratio that which is a volume of void over volume of solid or soil. So if you want to calculate void ratio, that uh, that is a volume of void which in a saturated condition all the area of water and air filled up with water. So volume of void in that situation is equal to volume of water. So the whole void is occupied with water in fully saturated condition. So that's a volume of water over volume of soil. Mhm. And for a water content percentage, that's mass of water over mass of soil. So we simply know if we subtract a wet mass of dry mass, it just gives us the mass of water over mass of dry, which is for soil grains, that gives us a 56 percentage of water content. So a W or water content is equal to 0.56. We already know we calculated the water content. We want to calculate void ratio, replace in a formula of SR times E equal to a WGS to calculate the specific gravity. Hmm. We know density of water is mass of water over volume of water. And we already know volume of void, which we calculated, is equal to volume of water. So, my bad, we are calculating volume of void, volume of water right now. So volume of water is just simply a mass of water, which we already calculated over the density of water. That gives us 0.114 cube meters. That's a volume of water. And also we do know volume of water is equal to volume of void. So volume of void is equal to the same amount of volume of water. And if we calculated volume of soil, that's a total mass minus V volume of void. That gives us volume of soils. So we know what total volume, what the total volume is. If we just replace the volume of water, it just gives us, and subtract that from the total volume, it just gives us a volume of soil equal to 0.079 cube meters, and a void ratio is just volume of void over volume of soil. And if you replace the numeric value, it just gives you a 1.44 for void ratio. And you can easily see for a void ratio, there is a possibility to get the higher numeric value than 1. And the physical interpretation of that is a volume of a void. You can have a bigger void ratio in comparison to soil. So the combination of air and water can be smaller and or bigger than the soil itself. So that's the concept of a void ratio. And if you plug in an SR times E equal to WGS, we already know what SR is. That's 1 for saturated soil. We calculated E to be 1.44, and we know we already calculated a water content, which is 56%. 1.44 times over 50.56 gives us a specific gravity of soil sample equal to 2.6. We can also solve this problem in a easier approach as well. So that's a solution 2. Mhm. In this solution, if we just directly calculate row total or row saturated, which in this case they are equal to each other, that's total mass over total volume, and that's 318 over 0.193, and it just gives you a saturated a density of 1647.67 kg over cube meters. And if you calculate a dry density, that's a dry mass over total volume. And if you calculate that based off of problem statement data, it just gives you a 1057 kg over cube meters. Mhm. And based off of void volume relationship, we do know rho dry density or dry a unit weight. The difference of unit weight and density is just rho times g is unit density. So the unit weight. So they are all the point is all the formula apply to unit weight is likewise apply to density. A the dry density is equal to total density over 1 plus moisture content. And if we just calculate the moisture content from this equation, we just get the a division of total density over dry density minus 1 gives us the same percentile for water content like a solution 1, which is 0.56. And again, SR times a, a E is a moisture content times GS. So if we know a water content is 0.56 and SR times E is equal to W times GS. SR is already saturated soil, so we have 1 for that, and E is, it just ends up to have E is equal to 0.56 GS. And also a dry density is GS over 1 plus E times rho W. We had the similar equation for a unit weight. If you remember, that was gamma D is equal to GS over 1 plus E times gamma W. And if we just replace E in this equation by the 0.56 GS, we can have a equation based off GS, which is the only unknown is specific gravity in this condition. So if you solve this equation for GS, a second solution also gives you a 2.6. It's up to you to uh, which approach the problem in which scenario, but to my understanding, solution 1 is easier. We'll solve a one more example on weight and volume, and I think we'll start the new chapter. Thank you.